Hi and hello. Today's lesson is going to be on operations we can do to polynomials. We'll focus on adding and subtracting for now, but we'll get into multiplying and dividing later. But we need to explore what exactly is a polynomial. Now we've been talking about them in the past. A polynomial of degree n is a function that looks like this. We'll have some number, we'll call it an, multiplied by x to the nth power. So we'll have a to the n minus 1, x to the n minus 1, and it'll just go all the way down until we get to our very last couple of terms, a times x to the first power, and then whatever our constant term at the end, a. This expression is called a polynomial. Let's consider these polynomials. X cubed, y plus 3y squared minus 5y cubed plus 10, a squared bc to the 12th, and 76. Each of these are a polynomial because each of these are the product of some number and some variable to an exponent. And I want to identify which ones of these are monomials, which ones of these have exactly one term, and which ones are polynomials, which ones are not monomials, which ones have multiple terms. So the important distinction is that each term in a polynomial is separated by addition or subtraction. So x cubed is a monomial because there's no addition and subtraction going on. The one that usually trips people up is a squared bc to the 12th. Even though it has 3 variables, this is still a monomial. And 76 is also a monomial because there's no addition, no extra variables. Which means our only not monomial is the polynomial with 4 terms, y plus 3y squared minus 5y cubed plus 10. So now I'd like to review degree. We'll take a look at each one. We'll identify the degree of each monomial. So the degree of a term is the sum of all exponents on each variable. So the degree of x cubed, is 3. The degree of a squared bc to the 12th is 15. You have to add up all of the exponents on all of the variables for each term. So then the degree of 76 is 0. So now that we've looked at the degree of monomials, I'd like to separate out y plus 3y squared minus 5y to the 3rd plus 10 into its terms. So remember, terms are separated by addition and subtraction. So our terms are y, 3y squared, negative 5y cubed, and 10. Those are our 4 terms for this polynomial. I'd like us to identify the coefficient of each variable term. So the coefficient of y is 1, right? The coefficient of 3y squared is 3. The coefficient of negative 5y cubed is negative 5. Coefficient is just the number in front of the variable. Now I'd like to go through and identify the degree of all 4 terms. So the degree of y is 1. The degree of 3y squared is 2. The degree of negative 5y cubed is 3. And the degree of 10 is 0. So in standard form, we're just going to start with the highest exponent, work our way down. So in standard form, we have negative 5y cubed plus 3y squared plus y plus 10. The leading coefficient of this polynomial is the coefficient on the term of the highest degree. When written in standard form, the leading coefficient is just the very first number that you see. So the leading coefficient of this polynomial is negative 5. And then the degree of this polynomial, you go with the degree of the highest term, it's 3. So that is a quick exploration into what polynomials are. Now we need to be able to do some math with them. So first we're going to look at what it means and how to add two polynomials. So I've got two examples we're going to look at, but really this is just going to boil down to combining like terms. So we'll go through two examples together and we'll lay each one out two different ways. So I'm going to take the polynomial 4x squared minus x cubed plus 2 plus 5x to the fourth. And to this polynomial, I want to add negative x plus 6x squared plus 3x to the fourth. So I want to find the sum of these two polynomials. So our first method is going to be to add vertically, kind of like if you were to add up and down if you have two relatively large numbers. So I'm going to lay each one out in standard form. And I'll try to do my best to make sure all of my like terms align, so that way when I add up and down, everything just kind of falls into place. So we'll start with 5x to the fourth minus x cubed plus 4x squared. However, I'm going to leave a little bit of space here. That space is for the x term, which we're missing, and then plus 2. That way, just in case, I don't accidentally combine any two variables that aren't like. So the second polynomial, I got 3x to the fourth. I do not have an x cubed, so I leave some space. Line up my 6x squared and my minus x. And so now we'll just add these two together. 5x to the fourth plus 3x to the fourth is 8x to the fourth. Negative x cubed doesn't have anything to combine, so it's just negative x cubed. Plus 4x squared plus 6x squared is 10x squared. Negative x doesn't have anything, and plus 2 doesn't have anything. So that is the sum of the two polynomials. Now let's try another one. 10x minus 18x cubed plus 6x to the fourth minus 2. And to this polynomial, I want to add negative 7x to the fourth plus 5 plus x plus 2x cubed. So we could add them together vertically, or instead we'll add them together horizontally. We'll rewrite each one in standard form, we'll identify all of our like terms, and then we'll just combine our like terms. So in standard form, it's 6x to the fourth minus 18x cubed plus 10x minus 2. That's our first polynomial. Our second polynomial in standard form is negative 7x to the fourth plus 2x cubed plus x plus 5. All right, so now that we've got each one written in standard form, we're just going to combine our like terms. So let's identify. So first we're going to take our 6x to the fourth and our negative 7x to the fourth. Those are like terms, so we've got 6x to the fourth minus 7x to the fourth, and we'll move down the line, just grouping together all of our like terms. So next up is negative 18x cubed and plus 2x cubed. All right, next up would be plus 10x and plus x. And finally, negative 2 plus 5. And then we'll just do each of our combined like terms. 6x minus 7x to the fourth is negative x to the fourth. Negative 18x cubed plus 2x cubed is negative 16x cubed. 10x plus x is 11x, and negative 2 plus 5 is 3. That is the sum of these two polynomials. Now, one important thing to note, the sum of two polynomials is always a polynomial. When you add or subtract, you will always have some combination of coefficients and variables to various exponents. But the worst case, the absolute worst case, is that when you add two polynomials together, you end up with 0, which is still a polynomial. It's got a degree of 0, and it's got a leading coefficient of 0. Still a polynomial, just not a very useful one. So now that we've talked about how to add two polynomials, we should be able to subtract two polynomials as well. So to subtract polynomials, again, it's going to boil down to combining like terms. I'll show you two ways to do it. We'll, just like with adding, we will subtract vertically, and then we will subtract horizontally just to make sure we see a couple of different representations. And I want to be clear, neither of these is the correct way to do it. You can use either method, whichever one works best for you. So let's start with this first example. We're going to take 12x to the fifth plus 5x minus 8x squared plus 19. And from this polynomial, I want to subtract the polynomial 6x squared minus 9x plus 3 minus 18x cubed. All right, so just like when I added two of them vertically, to subtract vertically, I'm going to write each in standard form, leaving gaps for any terms that we're missing. So I have 12x cubed minus 8x squared plus 5x plus 19. Below that one, I'll write the polynomial that I'm subtracting from it. So I'm going to subtract negative 18x cubed plus 6x squared minus 9x plus 3. Now it's important to note that we are subtracting down. So we're going to have to subtract each term. So 12x cubed minus negative 18x. Negative 18x cubed is actually going to be 30x cubed, right? Subtracting a negative is adding. Negative 8x squared minus 6x squared is negative 14x squared. Again, when you subtract a negative, it's adding. So 5 minus negative 9 is plus 14, and 19 minus 3 is 16. So the difference of these two polynomials is 30x cubed minus 14x squared plus 14x plus 16. All right, so for this second example, we're going to do our subtraction horizontally. So we'll start off, I've got the polynomial negative 4x squared plus 8x cubed plus 19 minus 5x to the fifth. Now from this polynomial, I want to take away, or I want to subtract 9 plus 2x squared plus 10x to the fifth. All right, so first I'm going to rewrite each polynomial in standard form, and then I'm going to be careful to distribute that negative. So my first polynomial in standard form is negative 5x to the fifth plus 8x cubed minus 4x squared plus 19. Now, I'm going to take that negative, and I need to distribute it to each of the terms. What that's going to let me do is that's going to let me turn this into an addition problem. So it's going to be plus negative 9, or plus negative 10x to the fifth, putting it in standard form, minus 2x squared minus 9. So that negative just has the effect of changing the sign of the entire polynomial. And then we'll identify our like terms, we'll group them. So negative 5x to the fifth and negative 10x to the fifth are like terms. So negative 5x to the fifth minus 10x to the fifth plus 8x cubed doesn't have any like terms. We can combine those two x squareds. So this can be negative 4x squared plus or minus 2x squared. And then we can combine that 19 and that negative 9. So all told, the difference of these two polynomials is negative 15x to the fifth plus 8x cubed minus 6x squared plus 10. So now the important thing to note is the difference of these two polynomials is still a polynomial. For the same reason, the sum of two polynomials is a polynomial.